Good morning, good afternoon, good evening, everyone. My name is Ryan Rodolin. I'm the Marketing Director for Water and Sustainability at Stantec. Thank you for joining us for our webinar series on the City of Atlanta Metro Integrated Biosolids and Zero Waste Program. A few housekeeping items. Just to let you know, you'll all be muted during the presentation. There will be a Q&A at the end, about 15-20 minutes, at which point you'll be able to unmute yourself and ask your questions, have a discussion. If you have a question while the presentation is going on, there is a questions option in the GoToWebinar panel. Feel free to type that in there, and we will ask those questions when we get to the Q&A section. With that, I'm going to turn it over to our speakers today, Mikita Browning from the City of Atlanta and Drew from Stantec. Take it away, Mikita.
Okay, good afternoon. I'm Mikita Browning. With the City of Atlanta Department of Watershed Management. I'm the interim commissioner with the department. To tell you a little bit about myself, I'm a native Atlantan. I'm also a former MWHer. I worked for Montgomery Watson Harza about 10 years ago before joining the city. Primary experience has been working on water, wastewater programs, stormwater programs, capital programs, and consent decrees. And so it's a pleasure to be able to speak with each of you today and give you some information, informative information about our latest initiative here for our zero waste initiative. And Drew, I'll turn it over to you.
Yep, so I'm Drew Whitlock. I'm a vice president and global practice leader for the Renewable Organic Solutions practice for Stantec. I have 25 years of experience and have specialized in energy recovery from anaerobic digestion processes, combined heat and power systems, renewable natural gas, and overall biogas utilization systems with clients all over North America and globally. Have a master's in business administration as well, so specialize in working through business case evaluations with clients and decision-making processes for projects just like this one. And I'll turn it back to Mikita and we'll go forward.
All right. So we have our Atlanta Metro Integrated Biosolids and Zero Waste Program. We've been pleased to have some steering committee partners, regional partners. We have 10 in addition to City of Atlanta that have been a part of this initiative for since its inception, the earlier part of this year. And so we're grateful for their commitment and participation, and just wanted to show recognition to those other utilities that have been a part of the conversation. Next slide, please. I'd also like to show some acknowledgements to City of Atlanta fellow colleagues that were also thoughtfully a part of the conversation. Rob Picaro, Quentin Fletcher, Justin Johnson, who's our deputy COO, Shelby Busey, who is she's a manager and out of our sustainability office, as well as Michelle Weissman. DC Robert Picaro is our deputy commissioner for Office of Engineering Services, whereas Quentin Fletcher is our deputy commissioner for our water and wastewater treatment facilities. And then we gratefully have, want to show acknowledgement for the program management services team, Stantec, that has supported this initiative since its inception. Alan Wong, Art Umble, Sharon Matthews, who's the program manager here, Larry King, who's a deputy program manager, as well as Elise Stoney. Program management services team, Stantec, continues to help us with a tremendous amount of our capital program and consent decrees, and just want to show acknowledgement to them. So program drivers, this really the basis of this is we've got current management and disposal practices of organic waste streams in the Metro Atlanta that are not sustainable. We have very few available landfills for disposal of biosolids. City of Atlanta does not have any city-owned landfills. Those were closed back in the 1980s. And so since that time, we've been hauling all our biosolids and municipal solid waste to private landfills throughout the state. And so, due to the increased landfill diversion of waste streams and the escalating landfill disposal costs in the region, we really need to be proactive and think forward about what are sustainable solutions for us to be able to dispose of our biosolids in an environmental friendly way. And so resource recovery from the waste is more environmental responsible, and we want to see how we can generate economic value from it. So we formed a steering committee back in January of this year. We've had several work sessions, very thoughtful work sessions with those other agencies and utilities to placate their interest in forming an alliance or a collaborative to think through the whole thought and conversation about biosolids disposal. And so again, it started in January. We wrapped up in September with an executive management workshop for the executive leadership across the utilities. Very good participation across the board, very good interest. Understanding that everybody has the same problem where we're recognizing that landfills are not as sustainable as they used to be. And we've just got to really think forward-facing about what the solutions are. So the steering committee sessions were had. This next slide is a summary of decision-making processes. As you can see, it's pretty much outlined. We had about 10 steps that we've taken over the past 9-10 months to get to this point. And we've thoughtfully determined what the waste streams are. So at the bottom, you'll see we've got wastewater residuals, fog and HSW, food waste, green waste that we're looking to be co-processed in a more regional approach for handling biosolids and those other waste streams. Next slide, please. This slide is the roadmap service area. So these are primarily the agencies that were part of the conversation. We did a very deep dive and thought about what facilities each of those utilities operated and how they could probably contribute towards the overall solution. In the end, we settled on one of the City of Atlanta major facilities, which is the Utoy Creek facility that you'll see there's a node on a map for. And we're going to continue to look at other viable facilities with these other stakeholders that might be, viable for secondary hubs for the overall initiative. So overall, we had 9 agencies and 19 facilities that have been considered to date. And I will turn it over to Drew to delve into the technology approach.
Thank you, Mikita. So the first thing we did once we got all of the various utilities on board was to, of course, do some projections on the amount of residuals from each of the wastewater facilities, as well as look at the food waste recovery, high strength waste, and fats, oils, and grease recovery that could be co-processed with this facility. So the table over to the left shows all of the different geographic areas and the various wastewater facilities that are included in those geographic areas, and then projected out the dry mass of material that would be associated with those out to the year 2030. Which was a total cumulative amount of over 300 dry tons per day. Then we went through really a binary decision process of where the best place to send that waste would be if we were to regionalize all of these entities that are included in the geographic area. And so we determined that based on the waste stream characterizations that we would transfer 152 dry tons to the Utoy Creek facility, which is really our energy production facility. And then we'd have 140 dry tons that would be transferred to this regional organics to soil center. And this is a little bit different breakdown and shows some of the temporal aspects of what we're doing. So on the top portion there, there's really an immediate need to try to relieve some of the financial pressure some of these entities are under. So at the Atlanta RM Clayton facility, there's a new thermal drying system that's being commissioned now and will be up and running. So one of the first steps is to take advantage of some of the excess capacity at that facility, design a import receiving system and co-process imported residuals at the RM Clayton facility to try to be as responsive as possible to release some of that financial pressure, as Mikita stated earlier. And then in the center portion, the next aspect of this is to design and build a regional organics to energy center. And I'll get into a little bit more detail on what that looks like, but that's really our facility where we're anaerobically digesting with an intensification process called thermal hydrolysis to produce as much biogas as possible and convert that to energy. And then we have Class A biosolids that would be transferred down to a new regional facility that would be an organics to soil center, where there would be some additional processing of Class B waste, and ultimately that would be stored and marketed and distributed for 100% reuse from that regional center. So at the Regional Organics to Energy Center, again, this is at the Utoy Creek facility, which is one of Atlanta's facilities. There are many steps that would be included in the intensification process. So the first couple steps are primarily, those would be handled at other facilities that are planning on importing waste to the Regional Organics to Energy Center. And those would include some steps for screening to ensure that all the debris is out of that feedstock. And then there would be dewatering of that to ensure that it's at the correct concentration for subsequent processes at the Utoy Creek plant. This would also include pre-processing of material such as food waste that would be separated out of the municipal solid waste, and to ensure it meets the specifications required for, again, processing at the Utoy Creek plant. At Utoy Creek, we would have a receiving system, a thermal hydrolysis process for pre-processing, a cooling step, anaerobic digestion system itself. We'd need steam generation for the thermal hydrolysis, and potentially a Sidestream treatment process for the return stream back to the Utoy Creek plant. This diagram shows the process flow diagram for the facility that includes the feedstocks over on the left-hand portion. There would be some indigenous material from the Utoy Creek plant that would include waste activated or biological sludge, as well as the primary sludge. And then that would be combined with the imported screened and dewatered wastewater residuals from the other facilities, as well as we're looking at up to about 100 dry tons a day of additional food waste, high strength waste, and fog that would all be combined prior to the thermal hydrolysis process. That is a high heat and pressure system that operates at 320 degrees Fahrenheit, and there's a batch process, so it meets Class A. Coming out of that, the material is cooled and then goes on to a two-stage anaerobic digestion system where we really squeeze as much of the energy out of the residuals as possible, and then those are recovered. In this case, we would be looking at a combined heat and power system to recover that, recovering the heat and converting that back to steam for the thermal hydrolysis process itself, and then final dewatering and out. One important factor with this is that with the level of material that's being processed at the Utoy Creek plant, it's important to have a plan for handling the return stream that will ultimately have to be processed. One of the important decision-making steps we took here was to ensure that we did have a Sidestream treatment plan. It's not necessarily about the Sidestream treatment, but it's really about meeting effluent limits that have to be managed. Some of these facilities in areas that are implemented remotely, there isn't wastewater treatment process to handle that side stream, and the economics become very challenging under those circumstances. So co-locating this facility, this energy recovery facility at the Utoy Creek plant is a very important factor, in having some additional liquid processing as well as solid processing systems at that plant improve the economics for all of the potential participants significantly. This shows an aerial view of the Utoy Creek facility. I'll point out some of the aspects of the additional assets that we had included in the process that I delineated in the previous slides. But one important factor here, again, this is such an ideal site. It's in an industrial area. There's access, there's interstate and large secondary road access to this facility. The facility has quite a bit of land available for use at the plant. That City of Atlanta has been looking at a number of different uses of this, but they determined that having this co-located regional facility at Utoy Creek, taking advantage of the land, the location, et cetera, would be really the right approach for this. The assets, again, that are included here are a receiving system that would receive the pre-processed material. That material would go into the thermal hydrolysis system. You see kind of in the center portion there, the thermal hydrolysis system creates Class A material. There's some dilution and need to cool the sludge before it goes into the anaerobic digestion system, but there are 4 anaerobic digesters at the facility itself. Each of those are 1.6 million gallons each, which provide a lot of the capacity needed, and we have the ability to expand those into the future. On the lower portion of the diagram, you'll see the green energy building that houses the combined heat and power system. And then over on the lower right-hand portion, there's a dewatering facility that would remove much of the liquid portion of that, and we'd have significantly dry material, Class A material, that would be transferred to the Regional Organics Soil Center. In sizing the system, we went through a sizing process to look at how many belt filter presses we would need for final dewatering, how many thermal hydrolysis units we would need. So for this, we looked at, we're planning on installing 6 belt filter presses that would have the firm and redundant capacity to meet the projected solids through this. We're looking at a throughput into the system of over 200 dry tons a day, and into the belt filter presses of something over 100 dry tons a day of material going to the belt filter presses. The thermal hydrolysis units are sized based on a Canby B64 system that has a capacity of over 90 dry tons a day. So we would need just over 2 units. So the plan initially would to have 3 of these B64 systems in place to handle the throughput based on the conceptual design analysis for this. Moving over to the biogas system, we're looking at 3 turbines for this, for the amount of biogas that we're producing. The estimated biogas production from this facility is quite significant, over 3 million cubic feet of biogas per day. When we run through the calculations and look at a power conversion efficiency of these turbines at 35%, we're looking at over 8 megawatts of power production from this facility. Again, 3 of these turbines would be installed 2 duty and 1 standby, so that we can provide continuous power for the City of Atlanta. As I said, the City of Atlanta had been contemplating several different uses of the land there. One of those was to look at a solar system on site. So the plan would be, in addition to producing 8 megawatts of power from the biogas production system itself, we would supplement that with a solar power system that could be located on top of buildings, and there is additional area there that could still be utilized for additional production. To enhance the site of the facility itself and the site, and to provide an amenity for the citizens of Atlanta and the local region, the plan would also to be to put in some kind of a learning center at the site. This really is such a broad vision and such an educational opportunity for local individuals as well as other facilities to learn from. We want to really provide some inspiration here and provide a facility that would allow individuals to come visit and learn about the facility and learn about how we're gathering waste, processing those wastes, and converting those wastes to energy and recovering the additional carbon and nutrients and utilizing them as well to make a full resource recovery system. Moving to the anaerobic digesters, the existing digesters, again, are 1.6 million gallons each, and they have adequate capacity for the initial phases. But if we need to expand those, we're looking at kind of building a tank within a tank. As you may recall from the previous diagrams, that there was tanks to expand that. So we're looking at building an additional 2 digesters as an expansion option in the future. And we looked at a number of different redundancy scenarios to ensure that there's adequate firm capacity within the system, which are shown, those are shown on the right there. So when we wrap this all together, we also wanted to look at, as I mentioned, that we're contemplating here this anaerobic digestion system that's really about energy conversion at the Utoy Creek plant, but we also have a thermal drying system at the RM Clayton facility, as well as there's another thermal drying system at the WB Casey plant that's owned and operated by a potential partnering utility. And then we also have this concept of composting material as well. So it really opens up a lot of options when we categorize these different feedstocks based on their the kinetics or the biodegradability of the material. We can really start to say, okay, if we have a strong management system with lots of levers to pull, how do we optimize that? Well, the material at the top that's readily biodegradable, including primary sludge, food waste, fats, oils, and greases, high strength waste, we'd really want to make sure we get that into the anaerobic digestion system, because that's the material that's really going to convert well to biogas. And then in the center portion, when we have biological sludge, the plan is to put that into the anaerobic digestion system. But green waste, that type of material, fully organic, but it's not going to break down in a conventional anaerobic digester. So that's really where we're recovering that and using that as a bulking agent for composting. And then the Class B material that's already anaerobically digested from other facilities would be combined with that green waste and go through the composting system. All the residuals would go to this regional organics to soil center, and then we would distribute that to market. Another interesting aspect of this is that the RM Clayton facility has a furnace system on site. So having those furnaces for backup if we have additional inventory that needs to be wasted from the regional organics to soil center, or if there's some sort of disruption in the market, having that backup system. But you can see the blue line is really, that's our main plan for waste management, with many different backup options, which creates a lot of flexibility with processing of these different substrates, and then having different material at the back end that can be utilized in addition to the biogas production from the Utoy Creek facility. When we look at the composting system itself, we went through a number of calculations for that on the level of material that we would be receiving, processing there with an advanced aerated static pile system, and calculated the area needed for that. This just shows a process flow diagram where the material that would be imported to this facility would be mixed with a bulking agent, composted, screened, cured, stored, and then out to market. And then if we combine all of the Class A material together, we're calculating that we'd need a required storage area just for the material itself of 17 acres. And then when you include all of the facilities and moving stock on the site and so forth, we're looking at a site of over 50 acres of land required for that regional facility. Again, we have 3 different products that we're looking at marketing from this. One would be a very nice composted product that you see on the left. We have pelletized biosolids that shown in the center, and then thermally hydrolyzed material on the lower right. Those with different types of material that can be distributed, and soil and green waste and so forth, that presents a lot of opportunities for a management entity to upgrade those materials, provide different products, and market those out to the state of Georgia. We have, for the Regional Organics to Energy Center, we have this Utoy Creek facility that's ideal for that, but we're still looking for and evaluating a new regional site for the Regional Organics to Soil Center, where all of the Class A material and the green waste would be received, processed, stored, and distributed. So we have a number of sites that we're looking at for that, but that remains to be determined and finalized from this. And as Commissioner Browning indicated, that we're also looking at taking advantage of these existing facilities for that as well. So I just have a few more slides here. I want to present some of the economic analysis of this. That was really one of the main outcomes that we wanted to examine, to look at the feasibility of the regionalization approach. And so looking at the Organics to Energy Center, we calculated that the capital cost for this facility is $250 million of capital investment for that. And then running through how we determined the cost of it, the net cost of this, we have a debt service that's calculated at $15 million a year. The operating costs for this are, when you add that to the debt service, we're looking at an annual cost of $21 million per year. We looked at some revenue sources from the biogas, as well as tipping fees for some of the imported waste, and so the food waste and the fog, fats, oils, and greases, and so forth. So that offset the $21 million a year by $10 million. So the net cost is calculated to be $10.8 million per year. And then when we convert that, basically divide that by the quantity of wastewater residuals coming into the plant, we're calculating over on the right-hand side that the unit cost for this is estimated to be $39 per wet ton, which is quite attractive considering the current cost of disposal for the facilities in the Atlanta metro region. Went through a similar calculation for the material that would be processed at the Regional Organics to Soil Center. We're looking at a capital cost of $45 million there. So when we look at debt service and operating cost of that facility, we were looking at $5 million per year. Calculated a bit of revenue from the green waste transfer into the system for a net cost of $3.9 million a year. And that happened, interestingly, our unit cost for that turned out to be $39 per wet ton as well for that facility. With that, I'm going to transfer it back to Commissioner Browning for going through the conclusions and next steps.
Thank you, Drew. So conclusions and next steps. The steering committee identified several benefits for all participants, the other agencies that we engaged in. To name a few, it's transparent and open book process. We thought that would be appealing to all of the other agencies. Shared benefits and risks, resource recovery from waste streams, increased landfill diversion, which we've spoken about before, beneficial reuse of products, capacity costs and revenue sharing. So we're able to spread the cost across all the agencies fairly. Something that Drew spoke about is the leveraging of our existing assets. It's important. And then some other things that we consider was just lower administrative and operational costs for shared assets. We also consider collaborative regulatory compliance and legislation would be helpful. There's also the potential component for regional community and workforce development, which I think is an area that is important to many communities, as well as just basically just shared values and information sharing and expanded communication across our utilities where we felt were benefits for all of the stakeholders. Next slide. So the anticipated next steps, again, out of the 5 agencies that we engaged, were based on where we are with current communication and coordination. We think we may look to have 2 to 3 to sign on to participate. And so the next steps, once we get that concurrence and agreement for those groups and agencies to participate, we'll look to negotiate letters of intent with the jurisdictions, research and conduct off-take market feasibility studies. We get to a point where we need to prepare bridging documents for the expansions of our existing City of Atlanta facilities. We look for standard bridging documents for regional receiving, composting, and distribution facilities. So that'd be a second phase of it. We prepare the permitting applications, the environmental due diligence that's needed, develop a comprehensive public relations and community outreach plan and program, and develop the ownership arrangements for the regional facilities. And that's where we're going to really look to hash out the governance that's going to be needed and rules of engagement for all the parties that are going to be a part of this the solution. Next slide, please. So out of all of the sessions, the work sessions that we had with the utilities, we developed a roadmap, and that really is our guide for us to pursue the efforts in the path forward to really realizing a regional facility or solution. And so what the path forward entails is, the management of a regional organic waste streams, economic regional solution that's, going to be identified. Again, back to that increased landfill diversion, green energy production and revenue, beneficial reuse products would be, the outcome and output. Increased regional collaboration, which is important to develop the synergy amongst the agencies that are going to be participating. Again, that capacity and revenue sharing model based on where it's beneficial, greenhouse gas reduction, and then, again, leveraging our existing wastewater assets for the betterment and the overall good of the initiative. And that concludes our presentation. We're open for questions.
Great, thanks, Drew and Commissioner Browning. Much appreciated. We do have quite a few questions here in the questions box, so I'll go ahead and ask these, and then after that, I will give everyone the ability to unmute themselves and ask a question live if they'd like.
Absolutely.
So first up, Drew, probably for you, I guess, or Commissioner Browning, why use a cooling step after thermal hydrolysis instead of converting the digestive process to a thermophilic process?
I'm going to defer that to you.
Okay. Yeah, so there's been some research on utilizing thermophilic step. You'd still need a cooling step. Out of the thermal hydrolysis system itself, there is some temperature decrease because it's a pressurized system. So once the pressure has been released from that, there's a bit of decrease, but there's still quite a bit of temperature loss that needs to happen through that. So whether you're operating at thermophilic temperatures or mesophilic temperatures, you would need a cooling step, but it would be more, the heat balance would be more favorable if we didn't need to cool quite as much. I think it's still an open question from a research standpoint, but can be in other investigatory outfits have looked at the thermophilic system, and in fact, I believe that can be looked at thermophilic digestion at the highest facility, which is really where they've done a lot of their research in the Norway area where that system was developed. And it just wasn't quite as stable with the thermophilic step. So they found that operating at mesophilic temperatures was a more stable approach to that, and have really standardized around that. Almost all the facilities, if not all of them, are operating at mesophilic temperatures at about 40 degrees Celsius.
All right, great. Another question about the solar panels that you are looking to put on some of the facilities. There was just a question about the ROI. Is that looking like it's going to be a good return? And if not, is there a premium that the city's going to have to pay to have those in there? I guess it's more of a nice to have or an actual benefit.
So I'll take that. I think, our approach is to obviously save on cost of energy and operations at our facilities. So we're still very much in the planning phase and really working through with a third-party vendor, and they've been in conversation with our Georgia Power, which is our regional power producer provider here in the state of Georgia, Atlanta, to really figure out what's going to be the cost savings for us and beneficial for us. We're looking at different scenarios for installation of the solar panels, and obviously looking to situate those solar panels at locations where it's going to reap the most cost savings and benefit for us. So it's still very much in its infancy, but we're working through the details. But obviously the option is the ultimate goal is to make sure that we maximize use of solar energy and energy savings at our facilities.
Great. Have you determined marketing options for the compost from the regional storage facility?
Shall I take that one, Mikita?
Yeah, not yet. Obviously, we want it to be as profitable as possible. I think that's something that will come down the road once we really try to figure out what the market is, is fluctuating. And so, but I think there's going to be a pretty consistent market for the composting and any output or byproducts of the facilities that we develop.
Okay, great. Did the operating costs for the regional facilities include a cost for use application of the compost pellets, biosolids, i.e. what costs were considered for distribution of the product?
Do you remember do we think about a cost
For the actual distribution?
Yeah.
For that particular aspect, since we hadn't really gone to the point where we have really an understanding of the market demand for the product, we assumed that we would get zero revenue from it, but we also assumed that the cost would be neutral from a handling standpoint downstream of the composting system and the storage itself. So there are of course operating costs, maintenance costs with the system itself and the assets associated with the processing, but we did not include any cost for the distribution of the product itself. In looking at the various products that we have and modeling from other large metropolitan regional areas, we felt that the cost approach that we use for that particular aspect was conservative because we didn't include any revenue from it. But there are some things like that still need to be determined as far as the ultimate disposition and reuse for that material, and what the revenue looks like that to offset the overall cost.
Ginger, I think to your point, we said we start off with not anticipating any revenue, but understanding hopefully down the road that we'd be able to realize some revenues and be able to incorporate that back into the O&M.
Okay, good. A question about emerging contaminants. Was there consideration given to any emerging contaminants in the end products, PFAS, microplastics, et cetera. Is there concern about that coming out of the waste stream?
We, like most utilities, we're watching the discussion of PFAS and other emerging contaminants very closely, and so it is a concern to us, and we didn't factor that into this analysis, but obviously once we get a little bit further down the road and get into the nuts and bolts of planning the facility and understanding what the regulations are with regard to those two components, we'll definitely be looking to infuse that into our thought process for processing and the outputs.
And these, it's a good question, and it's an important question. And these issues with microplastics and PFAS and so forth, and no doubt additional concerns that we will have at some point, down the road with other constituents and so forth. This, as an industry, we really need to accept that the management of these, of the residuals and beneficial use of it is part of the circular economy. It needs to be done, but it also needs to be done with prudence and continued research, continued investigatory work, and a lot of public education about the material, how it can be used safely and so forth. And ultimately, those types of issues, whether we regionalize the system or it's more of a distributed system as it is now, those issues are there and they're going to have to be dealt with. We feel like that those issues can be dealt with more effectively overall. When we scale up these processes, we have dedicated management for them. And I think that that's something to contemplate for other utilities that are looking at this as an example. That I think one of the advantages here is that because of the sheer magnitude of material that we're handling, that we can dedicate individuals, a team of individuals, to really manage this and optimize it, and also work on the distribution aspects as well as the public education. That needs to be really an ongoing process for our industry.
And Drew, to your point, I think the collaborative nature of the regional facility that we're contemplating and the combined knowledge base is going to be helpful for all the utilities involved, so that we can collaborate on, from a regulatory standpoint, what that needs to look like.
Absolutely.
All right, great. Lots of good questions coming in. Just a heads up, if I don't get to all of them, we will follow up with you individually and provide an answer. What centrate treatment technology is envisioned, and would it require a new tank, or would you be reusing an existing tank?
I'll take that one, Mikita. So whether we actually need a Sidestream treatment system is not to be determined. The Utoy Creek plant does have a significant amount of liquid and solid stream capacity available, and so we have not determined whether we need one or not. The process itself would likely be, from really a compliance standpoint, would be around dealing with the additional TKN, which is in the form out of the digestion process itself. That TKN is almost all in the form of ammonia. We weren't prescriptive about the type of deammonification system we'd use to handle that TKN, but there are good processing systems out there that can do it efficiently. So we wanted to include it in the price for capital and operating, in addition to the liquid stream process itself. So we just wanted, again, trying to be appropriately conservative with the cost estimates. We did include that in there. I will also say that the City of Atlanta has embarked on a struvite recovery system at the RM Clayton facility. So that could be employed as well, or another type of phosphorus recovery system that could be part of this. So that would be an enhancement, I'd say, that we could have an additional product that could be derived from it and recovered and reused.
Yeah, great. Okay. Has a carbon footprint analysis been done, or have you thought about doing one?
Sorry, I didn't catch. What's the question again?
Asking about a carbon footprint analysis for the program. Has there been one done? Are you considering doing one to see what the result will be, either reduction or increase? Hopefully reduction, obviously.
So no, one has not been done, but yeah, I think definitely we'd look to conduct one at the appropriate point in time. Absolutely.
Easy enough. What is your power cost per kilowatt hour? It's a little bit of a broad question there. I'm not sure exactly what. Yeah.
You know, for the calculations, I don't have those right up in front of me, but I believe that we assume that the cost as well as the cost offset for power is at 8 cents a kilowatt hour, which is, you know, when we look across the US, I think in the United States right now, the average is right around 9 or 10 cents. And then it can be higher or lower than that based on the retail rate of power distribution, state and region wide. There's quite a bit of variability in that, but 8 cents is what I believe we used for the calculations.
All right. Let's see, we've got some really specific questions here that we might hold off on and follow up individually. Let's see what I can ask here. What's the potential for nutrient recovery from liquid streams, such as filtrate from BFPs?
Yeah, as I indicated before, we did not include like a struve recovery system or another type of mineral that could be recovered in the cost estimate or in the revenue analysis, but that would certainly be on the table for this project, and perhaps could be included in the initial phase or could be included in subsequent phases quite easily. It would be, and again, City of Atlanta has already embarked on a process at their RM Clayton facility, so they understand how the system works, what the costs are, how to operate, and so forth. So it would make sense that they, you know, with the success of it at the RM Clayton facility, that they would want to employ it at the Utoy Creek plant in conjunction with this project.
Okay. What are you doing for public education and outreach on acceptance of the products? Do you have a dedicated committee, resources to do this outreach?
So with most of our projects, we try to develop a pretty comprehensive and robust community outreach and public education program. This initiative would be no different. I think it'll be, you know, great opportunity again, because we're going to be dealing with engaging other utilities and stakeholders and partners to be a part of it. And so we would make sure that we're engaging, you know, through the ranks of our agencies and identifying the community stakeholders that, you know, will take interest under, want to understand what we're doing and how it's going to benefit them and the community overall. And so I think it'll be a unique effort to be able to do this across, again, multiple utilities. But certainly we would look to develop a comprehensive and robust community outreach program. And with that, for any of the City of Atlanta Department of Watershed projects, we have a dedicated group that's all they do is really focus on public outreach consistently across all the projects and through the life of the projects, and engaging other community stakeholders. And so this would be no different.
Okay, that makes sense. Thank you. Let's see here. It says slide 12 mentions processing of food waste before sending it on. What does that entail?
We did include some costs that one important factor for this, I should say, is that we really were working through the Department of Watershed Management for the City of Atlanta. The Department of Public Works manages the municipal solid waste aspect of this, and so the concept here would be to receive as much as possible separated organics from the mixed waste that you would receive at a municipal solid waste facility, recover those at a material recovery facility, and pre-process them through screening and maceration and some dilution. Typically, this material is received at above 20% dry solids. It's sometimes as high as 35% dry solids. And what we're seeing standardized around these pre-processing systems and the dilution and so forth that's associated with them is it's typically delivered around 15% dry solids to make it pumpable, which is actually perfect for the thermal hydrolysis process and mixing with these other waste streams, because it provides a bit of dilution, but it's still pumpable and manageable there. So again, we weren't prescriptive on the type of pre-treatment system, but it would certainly require that, and those facilities are significant. The good news is that there's quite a few options with those, and the efficacy is quite good, and I'd say continuing to improve on the process mechanical aspects of the pre-processing of food waste.
All right. Question about tipping fees. Were they assessed for the substrate delivery and acceptance, such as fog and high strength waste? And if so, what amount is charged per gallon?
We did include a tipping fee for the fog and food waste. I think the average, we assumed different tipping fee values for that, but the average ended up coming in around 8 cents a gallon for tipping fees for that.
All right, very good. All right, okay. Can you elaborate on a comment earlier in the presentation about moving cake to the Clayton facility to relieve financial pressure? It says, is TD less costly than what otherwise is being done?
Mikita, you want to address that one?
I didn't catch the last portion of it. Moving.
It says, is TD less costly than what otherwise is being done?
Thermal drying, yeah.
Thermal drying, yeah. Sorry.
So we're still in our infancy with the thermal drying. I anticipate that, there would be some efficiency and reduction in costs associated with moving it, just from a transportation standpoint. And so we're talking about maximizing facilities and being able to, and the distance between that is probably one of our most central facilities. So I think there'll be some efficiencies and cost savings for being able to transfer products or outputs over to the Clayton Center. So I don't think there would be an issue there. I think it would be cost effective to do so. And the facility has the capacity to take it on.
All right, great. Let's see, what else do we have here? Did you evaluate RFS for RNG from the biogas? A lot of acronyms in that one.
Yeah. Did we I didn't catch quite that. You said RFS?
Did you evaluate RFS for RNG? I assuming renewable natural gas from the biogas.
Yeah. We did not look. As far as the economic analysis that were done is to calculate the capital and operating costs, we based that on a combined heat and power system. So all the economics were based on that. I would say that given the incentive programs that are out there and available to utilities, that renewable natural gas is a good option that we'll continue to look at, but the economics were not based on renewable natural gas production. But for those individuals that are out there contemplating that, there are incentive programs, federal and state incentive programs that do improve the economics significantly for that particular option. So we'll continue presumably we'll continue to evaluate that. There was
we talked about it initially, didn't we? But we didn't go down that path as we got further analysis.
Part of the it was partly, there's a solar system that's going in out there. So in conjunction with that and some of the rate agreements that were being negotiated with the power utility, that felt like there was some streamlining with the combined heat power system itself. But, I think the path we're on is a good path as far as energy recovery, but I wouldn't rule out the possibility of renewable natural gas production.
Yeah.
So.
Okay, good. Thank you. I'm actually with a couple minutes left here. I'm going to go ahead and unmute everybody. If someone wants to follow up with a question, they're welcome to. So I've given everybody the ability to unmute themselves. If you'd like to ask a question live, we have a number of other questions, but
This is Hassan from Pima County, Arizona. I just want to say that good job on the evaluation. Pima County, at this point, we're doing master planning, and that was beneficial to listen to this one. Drew and Mikita and team.
Thank you very much.
someone asked what the outcomes of the project are and if they're published somewhere. This is actually in progress. Drew, I don't know if we have I know you just did a blog, but I'm not sure if it gets into a lot of detail on the Atlanta program or not that someone could take a look at.
Yeah, so we're in the process of documenting and developing the roadmap, which is essentially what we've been charged with is providing a summary of the work that was delineated by Commissioner Browning, that kind of showed those steering committee meetings and the decision process. So we're trying to keep that fairly high level and really focused on the outcomes of that. So there will be some information that comes from that. The City of Atlanta, as I understand it, is going to be developing a series, continuing to put this out through the WEF Residuals and Biosolids Conference and WEF and continue to document, provide information as the program evolves. So I think there'll be some great information from that. And I'd just like to commend the City of Atlanta for taking a very strong leadership position and being willing to share that with other regions and other utilities as they no doubt are grappling with similar issues.
Thanks, Drew. I think adding to what you've said, we've been keeping this very high level, understandably. We spent most of our time in the past several months having those thoughtful conversations with other agencies. So at a certain point, we will be publishing more what these efforts have entailed for public consumption on our website in the near future. We're just really trying to wrap up the conversations that are needed before we can really be able to broadcast and share it. But we will definitely be sharing more and being present at the other water industry conferences and meetings and settings to share more about our journey towards a regional solution here.
That sounds good. And with that, we're at the hour. Just want to thank our presenters for joining us. Everyone that's still remaining, if you didn't see my note in the chat, I will be sending out follow-up certificates so you can register for PDHs from your local organization and providing a link to the recording. So thanks again to everybody that joined and to our presenters, and I hope everyone has a nice day.
Good. Thank you for having us.
Thanks, everybody. Thanks, Commissioner
Thank
Brown.
you.
Appreciate it.
Thank you.